Good afternoon, everyone. Today we are diving into one of the most important areas in cloud computing, cloud security. No matter how powerful our infrastructure or how fast our applications, none of it matters if the system isn't secure. So let's get started with the foundation, encryption, the digital lock and key of the cloud. When we store something in the cloud or send it across the internet, we don't want anyone snooping. So encryption takes plain data, what we call plain text, and scrambles it into a ciphered text using a key. If the key is lost, the data is unreadable. There are two major types. Symmetric encryption uses one key for both lock and unlock, fast, but you must share the key securely. Asymmetric encryption using public key to lock and private key to unlock. It's a bit slower, but perfect for the internet. And few of the common algorithms are AES, RSA, and TLS. That's the encryption for protecting your data end to end. Hashing is not encryption. It's one way. If you give it some input, could be a password or a file, and it gives you a short digital fingerprint. Even if you change one character, the fingerprint changes completely. Why does that matter? It's how systems verify integrity. When you download a Linux ISO, they often give you a SHA-256 checksum, so you hash your copy and compare. If it matches, the file wasn't tampered with. We also hash passwords before storing them, so even administrators can't see any passwords that the user has used for their logging in. So we only compare hashes during the login, and it's not reversible. Digital signature is like signing your name, but cryptographically. When I send you a message, I first hash it, then encrypt that hash using my private key. You, the receiver, use my public key to check if the signature matches or not. If someone changes even a single character, the hash will differ and the signature fails. That's why we trust updates from Microsoft or Apple. The operating system checks the vendor signature before installing anything. It provides two things: the sender is who they claim, and the data wasn't altered. Security groups. Security groups are your first line of defense in the cloud. They decide who can talk to your virtual machines and on which ports. For example, in AWS, you might say, allow inbound port 22 only from your university IP and block everything else. Outbound might be open for updates because they are stateful, but when your VM replies, the response is automatically allowed. No need for a reverse rule. Think of them as a programmable firewalls that move with your instance. It is much more easier than traditional hardware firewalls. PKI is the backbone of internet trust. Whenever you see the little padlock icon in your browser, that is PKI in action. A certificate of authority, or CA, is a notary that watches for someone's identity. When you request a certificate, the CA or the registration authority RA verifies you, issues a certificate, and lists it publicly. If a certificate is compromised, it's put on revocation list CRL, so when your browser visits google.com, it checks that a certificate chain verifying Google's public key is legitimate and is trusted. That's how PKI keeps e-commerce and cloud communication secure. Single sign-on, or SSO, is the magical moment when you log in once and everything just works. For example, if you log into your university email and suddenly Canvas, Teams, and OneDrive are all open without new passwords, that's SSO in action. It works by having a central identity provider handle authentication and then pass a secure token to each service using protocol like SAML or OAuth. It's also safer. Fewer passwords mean fewer chances to reuse or leak them. And for IT teams, all login activity is tracked centrally, which helps spot suspicious logins. When you spin up a new virtual machine, you don't want it to come with old vulnerabilities or useless software. A hardened image is like a pre sanitized template, clean, patched, and locked down. For instance, it might have unused ports, root login disabled, and unnecessary background services removed. That reduces what attackers can target. We call that minimizing the attack surface. Cloud providers often let you create a gold image, your own secure base virtual machine. So every new server starts in a known good hardened state. A VPN or a virtual private network creates a secure tunnel through the public internet. Imagine sending your data through a hidden pipe that only you and the server can see inside. That tunnel encrypts everything. So even if you're on your Starbucks Wi Fi, nobody can sniff your traffic. VPNs are also how companies let employees securely reach private cloud networks from home. In hybrid setups, VPN connect an on-prem data center to AWS or Azure so it behaves like one internal network. Biometric authentication is the something you are, part of the security. Your fingerprint, your iris, or even your face pattern can unlock a device. Unlike a password, this is something you can't forget. It is powerful, but it comes with responsibility. If a password leaks, you can reset it. If your biometric data leaks, it's permanent. That's why secure storage, often via trusted platform modules, it is critical in cloud systems. Biometric usually tied into larger identity frameworks like MFA or IAM, which we're going to get to in the next slides, adding that the final layer of assurance. Multi-factor authentication adds that one extra lock between hackers and your account. You might know your password, but the system also wants the proof that you are really you. Maybe a code on your phone or a fingerprint. Even if someone steals your password, they cannot log in without that second factor. In cloud, we usually enforce MFA on all admin accounts for AWS, Azure, and GCP because losing control of these credentials is catastrophic. Authenticator apps and hardware keys like YubiKey are far safer than SMS, which can be hijacked. Moving on to IAM, Identity and Access Management, is the brain of the cloud security. It decides who can do what. Every user, service, and role has defined permissions. For example, one student account might read files but not delete them. Another might have full admin rights. The goal is least privilege, only grant exactly what is needed. IAM also logs every authentication event, which makes it easy to audit. So if you think about it, encryption protects data, but IAM decides who even gets to touch it. Intrusion detection system is like a security camera for your network. It doesn't block traffic, it just watches and warns. There are two main flavors. Network-based intrusion detection system, which watches packets flowing through the system. Host-based intrusion detection system watches logins, file changes, and system calls on a specific machine. Signature-based detection looks for a known attack fingerprints, while anomaly-based detection looks for unusual behavior. When it sees something strange, say a login from another country, it raises an alert. From there, admins can investigate or pair it with a firewall to block attacks automatically. Penetration testing or pen testing is ethical hacking with permission. You pretend to be the attacker and look for cracks before someone else does. Tools like Nmap map your network, Metasploit tries known exploits, Burpsuit inspects web vulnerabilities. It is a control experiment to see how strong your defenses really are. In industry, pen testing is often required for compliance, like PCI DSS or ISO 27001, but it must always be authorized. Running scans on live system without approval can cause legal trouble. User behavior analysis takes security monitoring to a smarter level. Instead of just looking for known attacks, it learns what normal behavior looks like for each user. For example, if you usually log in from Missouri from 8 a.m. to 10 a.m., then suddenly there's a login from India at midnight. UBA flags it. It's often built on machine learning models that adapt over time. This helps detect insider threats or stolen accounts that bypass basic password security. It also reduces false alarms because it understands context better than traditional alert rules. A network intrusion monitor is like the air traffic control of your data center. It watches every packet flying across your network looking for suspicious patterns, things like port scans or unusually large outbound transfers. These tools integrate with IDS and SIEM platforms to give the real time picture of your security health. For example, AWS Guard Duty can flag strange traffic leaving an EC2 instance, suggesting it might be compromised. That visibility helps you react before serious damage occurs. Every login attempt, whether it succeeds or fails, tells a story. An authentication log monitor listens to those stories and looks for patterns. If a user fails 20 logins in 1 minute, that could be a brute force attempt. Someone logs in from two countries within 5 minutes, that's impossible travel, a clear red flag. Those logs feed into SIEM tools like Splunk and ELK Stack, which visualize and alert on those patterns. They are also crucial during audits or incident investigations. Your digital trail of who accessed what and when. Even VPNs need their own watchdogs. That's when VPN monitoring comes in. It keeps an eye on the tunnels that connect your users or data centers to the cloud. You'll see who's connected, how long sessions last, and whether latency spikes are causing disconnects. It can also flag failed logins or unauthorized connection attempts, a sign someone is probing the tunnel. In hybrid environments, a VPN monitor is a glue ensuring your cloud and on prem networks stay reliably and securely connected. And that brings to an end of our cloud security overview. Let's take a moment to step back and see how all of these pieces fit together. When you think about cloud security, imagine a layered defense. The encryption protects the data itself, IAM and MFA and SSO control who gets in, the monitoring tools like IDS, log analysis, and UBA watch what's happening inside, and testing and hardening keeps the system strong before attackers even get a chance. Each of these tools isn't separate, they are the parts of one secure system. And that is all for today's class. I'll see you again on Monday.